and welcome to Allot 360. I'm Michael Schachter, and we are here today with Jarad Carleton from Frost & Sullivan, Principal Analyst in Cybersecurity, and Ronan Priya, Vice President of Product and Strategy at Allot. And we will be discussing machine learning and artificial intelligence. Jarad, let me open with a question to you. Do you really believe that service providers are ready to let machine learning, artificial intelligence-driven software take over their networks?
I think that the concept of artificial intelligence taking over service provider networks is probably a little bit extreme. These tools are being used to actually help better manage the network and better secure the network. There are humans, however, on the back end that are using these tools to better understand what's going on, and they can then make decisions. There aren't any solutions out there right now that are fully automating everything. What it's doing is automating certain portions of jobs in the NOC or the SOC, and then enabling the analysts to go and make decisions in a much faster pace than what they were able to before.
So Ronan, we've heard a little bit about machine learning finding its initial ways into the network, but there's a lot of hype around it and a lot of buzz. How real is it, and what's actually happening in today's market?
So first of all, I think that when you talk about any type of management solution for a telecom operator, it's it's almost a classical ecosystem for machine learning. Machine learning is a technology which is based on the availability of data. It is learning. The machine is learning to produce better results, depending on the use case that you ask it to do, based on how much data that it has. And since telecom operators are sitting in the center of a big network where there is so much data, then this is, I think, the reason for the hype. It's clear to everyone that there is a lot of potential here of doing some kind of automation and automatic prediction of many different scenarios. So this is, I think, the reason for the hype. In reality, when you look at where the focus is at the moment in the market, or at least in the segment of the market in which Allot operates, which is where I think we know the market better, then I would say that the main focus, and like was mentioned here before, is about a better and more accurate network optimization and network management. Especially in the domains of the quality of experience of the subscribers, and looking for any automatic way whatsoever, and there are several different methods of doing it, to inform the telecom operator personnel that there is either an existing, already identified problem in quality of experience, or there is a prediction that a quality of experience problem is about to happen very quickly. And as was mentioned, they want to solve it, and if they can, they even want to prevent it before it happens. But at least they want to solve it quickly if it already occurred.
So what are some actual use cases? Quality of experience is an important concept, but can you drill us down to some actual examples where machine learning can actually help with that kind of a problem?
Okay, so the first use case I would mention is regarding the measurement of quality of experience in networks. We have several types of solutions and use cases for this. Let's start with video quality of experience measurement. When you talk about video transmission, like YouTube or Netflix, there are three main KPIs that you would like to measure quality of experience on. One of them is the time that it takes for the transmission to start after you press the play button. Mm-hmm. The second one is the resolution and decrease in resolution during the transmission. And the third one is stalls, when the picture gets stuck or the transmission gets stuck. Now, before those services were encrypted, it was relatively easy, or at least easier than today, to get this information by just analyzing the protocol, the command and control protocols of those applications. But this is not available for us anymore. So what we have today as input is a very big data set of bits, of encrypted traffic, which we get the bits. And based on this, we are trying to get to some kind of QoE conclusions. And this is where machine learning comes into play. We are using supervised learning for classification of different types of resolution, as well as classification of stalls during the call.
Sorry for interrupting, but what you do then is you teach the software to recognize from within this haystack of bits the actual needles of...
Yes, and machine learning and when you talk about supervised learning, you talk about actually by learning by example. How do you teach the machine? You give them a lot of example. Let's take the video case. We give them 500,000 YouTube transmission, and for each one of them, we tell them if there was a QoE problem and exactly in which second of the transmission. And then the algorithms of the machine learning are teaching the machine to identify those patterns and to make good predictions, hopefully good predictions, for future use. So after you teach the machine to, for example, to identify decrease in resolution, what you hope is that this machine will now, when it sees new input, it will tell you there is a very high probability, 95% more and above probability, that there is now a decrease in resolution challenge in specific YouTube transmission.
And Jarad talked about giving that information to the analysts to decide what to do. Is there also a mode in which the system, the solution, can leverage that by itself? Is that part of the solution?
So from technology point of view, of course, there is a way to create real-time automatic decisions based on this information. For example, if the machine is identifying that in a specific area of the network, like a specific CMTS in cable network or a specific cell in mobile network, there is now a few incidents in parallel of video congestion or video decrease in resolution. It is clear that the bandwidth in those areas of the network is not suitable to fit with all of this video transmission. If there are other applications in the same area which are with lower priority or with lower real-time requirements which you can decrease in priority, you can automatically solve some of the problem in real time. And the machine can make this decision by itself. However, like mentioned before, I don't think that most of the telecom operators are today in a situation where they will allow machines to make those automatic decisions. Mm-hmm. But I do think that they are open to this idea and that we will gradually get to this point. And it will require the machine learning models and the decisions that those machines are making to become better. Once they will be good enough and the telcos will be certain that they are good enough, I think that they can pass the psychological bridge of allowing those machines to make the decision for them, which is a big psychological bridge to pass.
Yeah, I agree with what Ronan was just saying. There's a lot of talk in the industry today about fine-tuning machine learning algorithms so that the service providers can trust them more to further automate some of the functions that they're meant to automate. Right now, as these machine learning algorithms are getting better and more fine-tuned, they are automating certain things in the network, but then they're bumping it over to the humans on the back end, who then they sit there and they look at it and they say, yes, this is actually correct, this is what we want to do, okay, press the button and have that action happen.
So what I'm hearing is that we're kind of still in early days, despite the hype, which is maybe a little bit ahead of the reality. And you mentioned the video QoE. Are there other machine learning AI types of solutions that Allot is currently bringing to the market?
Yes, I will give another example in another domain, which is in our security offering. We have various offerings which are focused on securing IoT devices, whether in the house or in the mobile network. Now, let's take the house case. Take a typical house where you have something like 5 mobile devices, 2 or 3 computers, and another 10 to 20 IoT devices. Smart meter, smart refrigerator, smart TV, whatever you want, and it's only growing. Now, when you want to employ security mechanisms, one critical item is which device in the house is behind which communication. In order to identify if a specific connection or specific communication from the house is suspicious from security point of view, a critical question is which device caused this communication. Or in simple words, if you see that your refrigerator is now contacting YouTube, Well, that might not be a logical thing to do, and maybe you have some kind of security breach. If you see that your computer is browsing to YouTube, it makes sense. Someone is watching a video. Now, when you try to deploy a security solution and you are sitting in the center of the network, you need to identify which device is behind every communication, which is not giving to you as an input. You have to identify it. This is another classical example of machine learning. By teaching machine learning algorithms the different communication patterns of different devices and different types of devices, you teach him how, for example, like a video camera is communicating compared to how a mobile cellular phone is communicating, because there are completely different communication patterns. It enables the machine to help you identify with good probability. Again, it's not a deterministic solution, but with good enough probability which device or which type of device is behind every communication coming from the house, and then this can be the basis for security decisions.
This is an important point, because some of these devices that are going into the house, they should only be communicating back to you. And the reason that is some of the devices you're connecting to the network in the home are actually doing things to help secure the home. And if they're giving information that's happening in the home to known malicious IP addresses in certain geographies around the world, or to IP addresses that aren't connected to your smartphone, for example, then you have to ask, well, who is also monitoring what's going on in my home? And that's another one of these issues of, understanding where these devices are communicating with, so that communications to other places they're not supposed to be talking to can be shut down.
So it sounds like machine learning is happening and AI is starting to power some of these solutions, and you've discussed a few that are currently part of the Allot offering. Can you give us a glimpse into what's planned, what's in the pipeline for additional use cases?
One of our biggest focus is trying to come with a smart machine learning model which identifies congestion in the network, in the RAN network, mainly of mobile service providers, based on information which we see at the core of the network. So we don't have information from the RAN, because Allot doesn't sit in the RAN. And in many cases, there is no clear information coming from the RAN, at least not in real time, about congestions. And still, the telecom operator would like to conclude that there is a congestion problem in a specific cell or a specific node B or a specific area or specific part of the network topology. And what we are trying to do is to conclude with good probability of being correct that there is such a congestion, looking only at information that is available for us at the core. Information about the connections coming from this direction and many of their technical parameters. And machine learning is helping us in trying to identify the right parameters and the right features which can actually be meaningful in doing such a prediction. It's not that we know in advance which parameters will help us. We are trying many different parameters, many different combinations of parameters, and the models are automating this process and helping us to find the best solution. And we are advancing in this significantly in the last few months, and I hope that we will be able to come with a good solution to the market soon.
As do I, because where I live in Austria, there's certain times of the year when it's heavy tourist season, such as winter ski time. And I've actually noticed that there's certain cells in my valley that get overloaded with traffic. And I'm not sure that my provider understands just how bad it can get, for example, around New Year's.
By the way, I would also mention that the big challenge with the machine learning is to identify that there is a congestion. But as I said before about video QE, once you identify it, there are usually simple steps that you can take as a telecom operator, whether automatically or manually, which will improve the situation immediately. And I'm really talking about simple classical prioritization decision between application. And there are many types of applications which are not real-time in nature, which you can decrease in priority, and no one will notice this, and still you will create enough, hopefully enough bandwidth to solve some of the congestion problem of the more urgent and real-time applications.
And I guess the business case for the operator is that on the one hand, they're improving the service and keeping their customers happy. And on the other hand, they're deferring, spending more money on expanding their network in order to keep up with this congestion, which actually isn't real congestion. It's congestion that's caused by a variety of traffic types, and some of them may be of lower priority.
Completely agree. And according to the business discussions that we are having with several tier one mobile operators, even a small decrease in the congestion of specific cells immediately resolve in major difference of capital expenditure. And capital expenditure in mobile networks are expensive.
Well, thank you, Ronan, and thank you, Jarad. This brings this session to a conclusion. I look forward to seeing you at the next Allot 360.